Hello class. In topic 3.6, sinusoidal function transformation, you will identify the amplitude, vertical shift, phase, period, and phase shift of sinusoidal function and how it correlates to the actual equation itself. Now, given the function in the form of a sine function, the following form, a times sine of b times theta plus d, and k of theta, where you have cosine of that, the graph of f and k have the following transformations. The value of a in both of these functions is going to be a vertical dilation, which represents basically the amplitude of the graph. So a for amplitude. The value of d here on both of these, that represents the midline, the vertical translation of d units. And it represents basically where the middle of the function is, so our midline. And a horizontal dilation by a factor of 1 over b, the absolute value of 1 over b, determines again the stretch of these things and represent basically how many cycles we're going to have in a period. So to figure out the period of that, we can use again that quantity and get 2 pi and divided by b, which in this situation will correlate to the following. That means that the value of b in this equation, let me do it in green, is going to equal to 2 pi divided by whatever the period is. So in this equation here, whether it's the cosine function or the sine function, we're going to end up again with this value of b there by getting the period and dividing it by 2. Okay, so let's look at the functions that we have right here. And let's say that this right here is a sine function, example number 1. And let's identify the amplitude, the period, and the midline, and how it corresponds to the values of a, b, and d on this example. Okay, well, as you see right here, our midline in example 1, our midline is the value of 3. That corresponds to the letter D in the formula down here. So that's that there. The amplitude, which in this example is 6, that corresponds to the value of A. The only thing that we have to actually calculate here is other than the period, is to find the value of b. The way we get the value of b in this equation is by getting 2 pi and dividing it by the period, which in this example, this sinusoidal function has a period of length pi. So pi divided by pi reduces itself out, and we end up with 2. So in this equation, the value of a equals to the number 6, the value of b equals to the number 2, and the value of d is the midline, which is the number 3. So if I put this again in this formula, the equation of this sine function would be this. Now look at example 2. The figure shows the graph of a trigonometric function f. Write the expression for f of theta. So let's again say that this is a sine function. And we want to figure out what the values of a, b, and d equal. We could start off by figuring out the value of d because that's easy to identify. That's the midline right here. Since the lowest point of our graph is 0 and the highest point is 6, the middle between 0 and 6 is the number 3. 6 plus 0 divided by 2 equals 3. So the value of d equals to 3. To figure out the value of a, all we now do is simply count from the middle to the highest point. So from 3 to 6, that's a difference of 3. So our amplitude is 3. The only thing we need to do now is determine again the value of b, which that gets calculated by first figuring out what the period is. So to get the period here, I'm going to look at the distance from 0, from this point right there, and look at the length of that one cycle starting from right here. And one cycle of this function, or of a sine function, because if I started the midline, that would be a sine function. One cycle of a sine function will look like this. Okay, so that has a length of pi units. So our period is equal to pi. Since our period is calculated by getting the largest x value, or the x value on the right, and minus the x value on the left, so pi. So that means that the value of b is going to be determined by getting 2 pi and dividing it by pi, and like the previous example, that's simply equal to 2. So there's the values of a, b, and c. Let's look at example number 3. The figure shows the graph of a sinusoidal function g. What are the values of the, again, a, b, and c of this function right here, okay? So when it gets the sine function, in this example, we want to do this. We have this function g of x, and we want to know what's the value of a, b, and d going to equal here, not this part right here. So we're not looking for that, okay? So let's look at this example here. So before we figure out the values of a, b, and d, let's identify the midline, our amplitude, and our period. So our midline is -1. Our amplitude is the distance from -1 going up, so that's a total of 2 units. Our amplitude is 2. And to figure out our period, let's start here in the center. So here at 0. And let's look at this cycle right there, okay? So from 0 to pi, that equals to pi. So our period is pi. So now that we have that, let's figure out what the values of the are going to be. So our midline is going to be -1. So value of d equals -1. Our period is pi, so that means that the value of b is going to be 2 pi divided by pi, which is just 2. So b equals to that. Now, what is the value of a going to be? Now, the value of a would normally be +2. But if we look on the y-axis, again, right here, where our sine function is starting at, our sine function starts here on the y-axis. Instead of it moving up like it normally does, again, let me draw a sketch of what our sine function looks normally coming off the y-axis. So at 0, the sine function goes up and then goes back down. So for this example here, since it's going in the opposite direction off the y-axis, it's going down and back up, then that means that the value of a, which correlates to the amplitude, is going to be a reflection of this. So our value of a is not going to be a +2, it's going to be a -2 in this situation, because we have a reflection of our normal cycle for sine. So we have a negative cycle of sine because we're going down and then up, instead of going up and then down to the minimum value. So, and that affects again the value of a. So our amplitude is not +2. I'm sorry, our amplitude, well, our amplitude is +2 because our amplitude is correlating to a distance. The value of a in the equation is going to be negative because of the direction that we're moving from the y-axis. Let's now discuss phase shifts of a sinusoidal function. A horizontal translation of a sinusoidal function is referred to as a phase shift. Okay, the graph of f of x is equal to the sine of x plus c is a phase shift of the graph of f of x of sine of x by c units. Now, even though the notation is plus right here, as for the AP test, the idea is still the same. If I need things to shift to the left, I need this notation right here to be a plus. And if I need things to shift to the right, I need this number right here. When I add whatever this number is, I need it to be a negative value, again, to shift it to the right. And if I shift it over here, this notation will look like plus some number, okay? Now, the reason that they have it like this is identifying, again, what that value of c is, because we're going to kind of work backwards right here. You'll make sense when I give you an example. Okay, now the two forms when I include the phase shift for sine and cosine is this: g of x is equal to a times the sine of b, and here's my phase shift, of x plus c plus my midline. So including all the transformations, the vertical dilation and translation, along with the horizontal dilation and translation, this is what the sine function will look like. And if it was a cosine function, g of x will equal to a times cosine of b, parentheses, x plus c, close parentheses, plus d, your midline. Okay. Now the only thing that's going to change and shift on these two is going to be this value of c. Okay. That c could be a lot of different numbers and still be considered to be the same answer to the graph that we have, and it'll give us the exact same picture as we'll see right now. So let's look at example number 4. Since the quantity c is the only thing that changes, the values of a, b, and d do not change whether it's a sine function or a cosine function. So let's find out what those quantities are going to be. So to figure out the values of a, b, and d, let's start with d because the d is the midline. So we're going to get the lowest point, -4, add it with the highest point, +2, and divide that by 2, and that's going to tell me the middle. So our middle is -1. So our midline is right there. Since our midline is there, from there to the highest point, that's a total of 3 units. So our amplitude is 3, since it's counting by 1, since our y-axis is increasing in increments of 1. Now to find our b, we're going to look for the period first. So let's look at this. Let's use this number right here. So from this point to that point, so the distance from here to there is determined, our period is determined by getting the value on the right and subtracting it by the x value on the left. So 3 pi minus 1 pi is 2 pi. So to calculate the value of b, like in the previous examples, we're going to get 2 pi and divided by 2 pi, which is equal to 1. So that's going to end up being 1. Okay, so here is our function. So g of x, there's two options. G of x, if it was a sine function, would be 3 times the sine of the value of b, which is 1. So we're not going to write that number right there. 1 times all of this is just going to make this look the same. So we don't have to write the value of 1. We could just write x plus some value of c and our midline, which is -1. So that's one option if we're using sine. If we're going to use cosine, it'll look basically the exact same way, and the only number that's left to find is going to be, again, this shift. How are we moving from right here? Okay, now the best way to figure out what that value is going to be is by looking at the original function and moving that point to the y-axis. How many values do we need to move it to the y-axis? And since we're moving it to the left, okay, it's going to be a negative sign. Now, again, I know we talked about transformations being moving to the left has to be positive, but that's only from the original one, okay? If I'm moving the original function to the left, that would have to be a positive value right there, okay? But we're doing this backwards. We're not looking at where the original is and moving it to its corresponding new location. We're looking at the transformation and then moving those points to the y-axis and seeing what direction that is. And that's going to be easier so we don't make a mistake in determining if that's going to have to be a positive number or a negative number, okay? So that's why we're going to look at it like that. And that's why we're using the sign of plus, because we're not going from the original function to the transformation. We're going to go from the transformation back to the original function. What would I have to do in order to move it back to what it originally is, okay? So let's refresh ourselves on some concepts. Well, a sine function, let me erase all of this. I don't need this anymore here. Sorry, I know that you're not going to have enough space here. But let's talk about our two functions. Our sine function normally on the y-axis starts on the midline, goes up, goes down, and goes back up to create one cycle, okay? So that's what that value is. And our cosine function on our rectangular grid starts at a maximum, goes down, reaches a minimum, and then stops again at that same maximum value just further along the x-axis. So that's what one cycle looks like, okay? So to figure out what this value of c is going to be on whether it's sine or cosine, we're going to do the exact same thing, but backwards. Instead of trying to figure out how many units I moved it from the origin 0, 0 to the left or to the right, I'm going to find a point that's on the midline for sine. So let me highlight my midline and simply see what that value is and how many units I need to move it back to the origin. So like in this example, if I look at this point right here, which is at pi over 2, I can move this point back to the origin by moving it pi over 2 units to the left. And since I'm moving to the left, that would have to be negative pi over 2. So, and since a positive times a negative is a negative, that equals to negative pi over 2. So my value of c for this one right here, one option is negative pi over 2, okay? Now, if I look at the original one, ignore everything else. Let's assume that it's going to start at the 0. That means having this as a negative, we'll move it to the left. We'll move the original one to the right, not to the left, but to the right, pi over 2 units, and put this position right there at pi over 2, okay? So right there. So in terms of what's happening to the original function, yes, it's still going the same direction, and the rules are still the same. And it's going to be moving to the left because this is negative. So the way we're finding that number, however, is just using, again, the opposite direction. That way we could get the sign correct, okay? And we don't make a mistake with the sign. So we're going to move it. I know it's kind of bothersome, but it makes it easier to figure out what the shift is going to be. And we don't have to worry about, okay, how many units am I moving over? So if I figure out what the shift is and where that original point is, the first point on the midline, that where the graph goes up, I know exactly how many units I can move it there, okay? Now another example, let's call it h. For this sine function, another possible shift for this sine function would be if I moved it from over here. Let's do this one over here in orange. It can't be this one because this, even though this point is on the midline, this cycle of the function goes down and my sine function always goes up first. So I can't use this point and shift this in that direction because it won't give me, again, this function right here. But I could use another point that's on the midline right here, 5 pi over 2, and create another cycle of sine from 5 pi over 2. So if I shift the graph from this point, okay, back to the y-axis, negative direction, this could be another transformation of this original function right there, okay? Normally, again, with all the other information that we have about sine, our amplitude is normally 1. Okay, our period is worth 2 pi. From here, 0 to this point right there is 2 pi. We have changed all of this because of these values here, okay? And the midline is normally right here at 0. So shifting it down, shifting the midline from 0 to -1 is that. Having the amplitude go up all the way from 1 to 3 is that. And now shifting it again from 0, 0 to this new position is going to be -5 pi over 3. And like I said, it's easiest to figure out what that value is by looking at where the starting point is and how many units I would have to move it back to the y-axis to figure out what that shift is. So this right here would be the answer. Okay, and that's a second possible shift that we can do. And like I mentioned again, depending on which start off will determine again the shift that I can add to this x. So it would be this value right there. Okay, and I could do the exact same thing with cosine. The only difference is, since cosine starts at a max, I would just simply have to look at a max value on the graph. And I have two possibilities, okay? If I shift it from this point back to originally was, that would be a shift of pi units. And since I'm moving it back to the original y-axis in a left direction, that would be negative, which correlates again back to the original notation. So if I start here and I subtract pi, that's going to move it in a positive direction. That will move the original one in a positive direction if this is a horizontal shift of minus pi. So like I said, I don't want to work with the original one and try to figure out, okay, how many units I'm moving it over. I just want to look with the transformation and work that way and work backwards, so I know what the sign is going to be as well. Okay, or I can also do this. If I look at the graph from this max, which is at 3 pi, to move it all the way back over there, that would mean that the original one at 0 would have to move all the way over there, total 3 pi. So to move things to the right, that would have to be a negative value. And again, it just correlates to this. It's easier to see it from right here. Correlating over here, moving it to the left, would have to be a negative value. So negative 3 pi. Okay, so there. Those are the possible shifts. Now, I did mention, well, what happens if I use these 2 points? If I use this point over here for sine, and I look at the cycle of sine at this point in the midline and decide to go down and reach the minimum before I go up and reach the maximum, and then stop at the midline again and look at one cycle of sine like this, I can still shift it and get to this value of plus negative 3 pi over 2 and do that shift. But unfortunately, since the graph is going downwards, that is going to change one number. It's going to change the amplitude. Instead of the amplitude being a positive number, it changes this value of a to a negative number. The amplitude is still 3. I should rephrase that. The amplitude is still 3, but in terms of what the value of a is, it just simply switches it to a negative value. Okay, it reflects it. In other words, we do a vertical reflection along with the vertical dilation. And the same thing can be true about cosine. I look at cosine, and instead of starting at a cycle where I go at the max, go down and go back up, okay, like I did right here, and shift it pi units to its original location, then I can start down here, go up and go back down, and shift it to 2 pi units. So I could change this to plus negative 2 pi. And the only difference would be is that this value for the value of a would just have to be negative. That's all. Okay. So there's a lot of, like I said, a lot of different ways, and these phase shifts can be really, really confusing. Again, you could easily get lost on this. So I highly recommend just starting with the first one. Okay, look for the first value for sine, and I like sticking with sine to create these equations and moving it from that point on. Okay, and since we're looking from the shift and trying to convert the shift back to its original one, that's going to help me determine again what the sine value is going to be, whether it's going to be negative or positive, since I'm not working with the original to determine, okay, do I have to move the original to the left or do I move it to the right, and what sign that's going to be. I stick with the transformation and move these points, whether it's the point on the midline or the maximum, to the y-axis. And if I'm moving those points to the y-axis, and if the y-axis on the left side, then those numbers have to be negative. But if the y-axis were to be on the right side, then those numbers would have to be positive. Okay, and that's the only difference. And I like, again, working with positive numbers for A. And if I'm going to write this. Now, if it was a multiple choice, then there's probably you might not have an option. And you would have to look at these situations where we have negative values of A, which means that it's going to be a reflection of your sine function, the reflection of that would start here and go down, okay? Or a reflection of your cosine function. So you'll start here and go up and then back down, okay? And for cosine, there's another one. Let me write on the other one for cosine. The other option for cosine, if I'm going to have a -3, is to do no type of reflection. I'm sorry, no type of shift at all, no phase shift, because since this point is already starting at the bottom right here, and it goes up and it goes back down and stops at this point. Let me erase this. So this creates, again, no phase shift, and you don't have to move it because you're already on the y-axis. So you shifted a total of 0 units. So if that was the case, this is another option for the equation for cosine. X plus 0, which is just x, plus the midline, which is -1. So now let's look at this example 5. The figure shows the graph of a sinusoidal function, which could be the expression of h of x. Again, so we're going to do 2 for h. We're going to do 1 for sine, and 1 for cosine, just to practice both of them, okay? The value of A, B, and D are going to be the same for sine and cosine, so let's find those. The midline here is 1. 3 plus -1 is 2. Divided by 2 is 1. So this is our middle. The amplitude from 1 to 3 or 1 to -1, that's a total of 2. And now let's figure out our B. Let's get our period. So let's do these whole number ones. This is a whole number. This is a whole number. So our period is 2 pi minus pi, which is equal to pi. So the value of B would be 2 pi divided by pi, which is 2. Okay. So for H, with cosine, it's 2 times the sine of 2, parentheses, x plus some shift, plus our midline of 1. And if we're going to use cosine, all those numbers are the same. Except for our... So let's see what our phase is going to be. It all depends on, again, where I want to start. Let's do the cosine first because that's going to be easy. All I have to do is find a maximum value. If I want this value of A to be positive, find the first maximum value and then shift it from that point. So the first maximum value I see, which is at pi over 2. So that means that to get to there, I would have to shift it to the right, to the original one. I'm talking about the original one. The original function looks like this. I would have to shift it to the right, pi over 2 units, to move that point from 0 to that location. So if I think about this backwards and I look at this function right here, at the transformation, at the shift, I would have to shift this back to the left, pi over 2 units, so minus pi over 2. So that's what I like to do instead, okay? Instead of thinking from the original, I like to look at the phase shift and how many units I would have to move it to the left or to the right to get back to the origin. Not to the origin, but to the y-axis, So this, I would have to move it to the left, so negative pi over 2 units, okay? Or I could do this point and move this one to the left, so it could be 3 pi over 2, 5 pi over 2, minus 7 pi over 2. It could be in any one of those, okay? Now, had I used the negative values and used these bottom points, I could still do that. But the equation, let me do it in red for the negative, would just simply be minus 2 times the cosine of 2x plus those possible numbers. So plus a negative 2 pi, negative 1 pi, negative 3 pi, negative 4 pi, or 0, because this one is already starting at the bottom. So I could even use just 0. If it was 0, that one I do want to write that one, okay? This would just be 2x plus 1, because I'm not going to shift that at all. I'm already going to start down here at 0, okay? Now, let's see what the options are if I wanted to write it as sine, or the instructions were to write it using sine. To using sine, well, I would have to find points that are on the midline. So let me plot those in purple, okay? All these points right here on the midline, and move in that direction, and move those points to the left to the y-axis. So that would have to be a negative number in order to move the transformation back to its original position, okay? So figuring out what this value is, well, that would simply just divide again. This point is exactly in the middle with all these functions. The midpoints, since this is where the maximum is and this is where the midpoint to this value right here, this point right there is always halfway the distance between a max and a min, between any max and min. So the distance from 0 to pi over 2 pi over 2 minus 0 is pi over 2. Let me write it bigger. So pi over 2 minus 0 is pi over 2. And the middle of that, since that's the distance from here to here, that's that distance, to figure out where the middle is, I simply divide that distance into 2 equal parts. So pi over 2 divided by 2 is the same thing as multiplying the denominator by 2. So this is pi over 4. So this value right there is going to be pi over 4. So there are increments again of pi over 4. And that would be my shift. So to move this point over here, I would have to subtract pi over 4. Or if I think about the original function, and I think about the original sine function that has the middle at 1, it would have to go up at 1 to 3. And then negative 1. The graph will look like that, okay? Where this is the origin. But I want to move that from that position to this position, which is pi over 4. And to move it to the right means that this number would have to be negative. But like I mentioned earlier, I'd prefer, again, just looking at this. If you start right here, moving to the left makes things so much easier. So moving to the left, that means negative. So negative pi over 4, okay? So there. And if I do this one, I would just have to figure out what the distance between these two are, which again is going to be some quantity, and I just find the middle value between those two. Okay, so the same thing, I find the midpoint between those. So that's all I have to do, find the midpoint between those values. And to find the midpoint, just use the midpoint formula. So add those two quantities together. So 3 pi over 2 plus pi I should meant to do plus up there also, okay? Because I want to find the middle, not subtract. It just worked out because it was 0. This is going to end up being 5 pi over 2. Divide that by 2. And my middle is 5 pi over 4. So if I want to shift it from right here, that would be 5 pi over 4. And of course still negative because we're on the right axis. Let's now practice the AP problem using again this phase shift. Now the tire of a car has a radius of 9 inches and a person rolls the tire forward at a constant rate on ground level as shown in the figure. The point W on the edge of the tire touches the ground at t is equal to 1/2 seconds. So right now, as you see right here, this point that we're interested in is not on the ground. And from this position till it reaches the ground, the amount of time that happens there is 1/2 second, okay? Now, the tire completes a full rotation, and the next time W touches the ground is at t equals 5/2 seconds. So from this position all the way over here, okay, until it reaches back at the bottom, a total of 3 seconds have occurred, right? So from here until it touches there, 1/2 second has occurred, and then 5/2 seconds occurs until from here to go back around in a complete circle. The maximum height of W above the ground is 18 inches, and as the tire rolls, the height of W above the ground periodically increases and decreases, okay? So let's figure out again the same situation as before. Let me clear the page. And let's look at what the values of the coordinates of F, G, J, K, and P are in this scenario, in this type of situation. Well, first thing we're going to look is identify the Y coordinates here. Since the radius of this thing is 9 and the maximum height is going to be 18, it says so right there, we know that this value right here is going to equal to 18. And well, when W is on the ground level, when W is touching the ground, it's going to be 0 inches from the ground. Okay, I kind of glossed over that, but let me emphasize this, okay? The graph of H in this dashed midline has 2 full cycles. Find the coordinates of this. So the sinusoidal function H, here it is. The sinusoidal function H models the height of W above the ground. So when it's touching the ground, it's 0 inches from the ground. And then when W is up here, where this person's hand is, then it is 18 inches from the ground. And to figure out where the height of W from the ground, when it's in the middle, when it's at the person's knee here, or away from the person right here, well, that's going to be midway between the bottom and the top. And the middle of 18 and 0, that equals to 9. So those are the Y values for F, G, J, K, and P respectively. Now let's figure out what the times are when that point W is going to reach this maximums, these mids, and the minimum. Okay. Well, we know that the first time it reaches the minimum is at 1/2 second. So at this point right here, it's not going to be 0. This is going to be 1/2. And the next time it reaches the bottom, so right here, and it reaches the bottom of, that's going to occur at 5/2 seconds. So 5/2 isn't the amount of time that it's lapped. That's the time that it's at point W. At the point W is at the bottom again. So that would mean that this time at point J, this point is going to be at the bottom again, and that's going to occur at 5/2. So I'm looking for the X coordinates for all of these. Okay, so J, K, and I should probably move these over a bit. And P. Okay. Well, I know what the Y coordinates are going to be for all of them already. At F, it's going to have a Y coordinate of 18. G9, K, J is going to be 0. K is going to be back at 9. And P, 18. So I have that down. Okay. I know at J, 5/2 seconds. At 5/2 seconds, W is going to be back on the ground. Now to figure out what the increments are going to be between every quarter turn, I'm simply going to look at the period and divide that by 4. So our period here would be 5/2 minus 1/2, which is equal to 4/2 divided by 2. Okay, so the period length would be from here to there. Now normally it's this number right there, our period matches to this, but because we normally start at 0, since we're starting at 1/2, it takes 1/2 of a second until that point W reaches again the ground. And then at 5/2 seconds, not 5/2 more seconds, but at 5/2 seconds when it does it again, the period would be the distance between those two x values. So 5/2 minus 1/2, like I said, is equal to 2. So that means that each quarter turn, our increments of t, our increments of time, each quarter turn, so the time it takes to go from here to there, and then from here to the top where the hand is, from the hand to this position right there, and then from right here back to the bottom, would be 2 divided into 4 quarter turns, so 1/2. So it takes half of a second to make a quarter turn. And since I'm starting here at the bottom, 1 quarter turn would be 1/2 higher, so 2, 3/2, 4/2, 5/2, perfect, matches up, 6/2, and 7/2. So our times here are 3/2 for F. G has a 2/2, which is just 2. J we already got. K is at 6/2, which simplifies to 3. And P is at 7/2. And there you have it. We have the coordinates for F, G, J, K, and P. Now, part B, we're going to do something different here. Instead of identify the amplitude, period, and midline, we're going to refer to those things as A, B, C, and D on this equation. So the function h can be written in the form of h of t equals to a sine function. So pay close attention to that. It's a sine function. And we want to find the values of A, B, and C. Oh, and D. Okay, so let's start off with D. D is the easy, that's the midline. Well, our midline right here is the number 9. And from the midline, we can identify the amplitude because the distance from 9 to 18 is also 9 units. So our value of A is 9. Now to find the value of B, we're going to get 2 pi and divided by our period. And our period is 2, not 1/2. 1/2 is the time it takes to make a quarter turn. Our period, the length of one full rotation, is 2 seconds. And 2 pi divided by 2 is equal to pi. So the value of B is pi. And the only thing left again is to figure out our phase shift. What is the value of C? Well, since our sine function, again, starts at the midline, goes up, goes down, and goes up, okay, from the y-axis, I'm going to see where the first shift of sine is created and use that point. So on the midline going up, the first shift of sine will go from this position of time equals to 2/2 to point K. So this point right there. And since this 2/2 is equal to 1, our y-axis would be to the left of that. So to move it back to its original position, I would have to move it to the left 1 unit. So the value of C is -1. And that makes sense. In order to move this position to the right, I would have to have x minus a constant to move it to the right. And that value would have to be negative. So -1 to move it back right there. Okay. Now, another option is that I could also create a sine function. Let me erase this right here. Let me erase this. I can also create another cycle of a sine function if I start at K, a positive cycle of a sine function if I start at K, go up, and then go back down, okay? So for the AP test, it would also be acceptable to use this position and shift this graph, the original function, okay, the original sign, all the way over there to +3, okay? So -3 would be another acceptable answer for the AP test. For your homework, however, for these practice problems I'm assigning you for homework, do this one right here, okay? Make it easier on myself and just use this point right there and shift whatever this point is to the left. So in a negative direction, so you could end up with a negative value of whatever this value is, okay? So practice that one and use that one for these type of situations. Okay, that concludes these examples for 3.6. If you have any questions, send me a message through email or Parent Square. And like always, I appreciate you watching, and I hope you have a great day. Goodbye.